Hello everyone, thank you very much for having me here. I am Melinda Bogna and I am going to talk about my research project From Intuition to Randomness, Combinatorics as Architectural Design Methodology in the Wave Function Collapse Algorithm. The presentation is going to show an epistemic approach to planning with a more detailed look at the casualties in the digital turn. Here you can see the structure of the following presentation. Firstly, I am going to investigate the hint of design theory, then the development of the wave function collapse algorithm, its application, a bit of experiments, and finally, I'm going to share my conclusion on the topic. Architectural design methods have doubtlessly changed due to the digital paradigm shift. The linear workflow of design turned to a loop, and the level of human abstraction in each design phase are led by algorithmic computation. Facing this phenomenon is a puzzle for many professionals. Instead of designing the exact output of an architectural work, digital allows to plan the method of creation with possibly similar but not necessarily identical results. This paper, through the examination of the wave function collapse algorithm, highlights the ideological tensions compared to the traditional design process by showing how the human intuition can turn to a machinic randomness. Comparing traditional architecture with digital aesthetics, a significant difference appears in the design process. While traditionally, architecture aimed to design the final physical outcome, with digital tools now it's likely to design the procedure and let the outcome differ from time to time. As Mario Carpo argues, this is one of the main characteristics of digital reproduction with the same method, resulting in always similar but not identical outcomes. In previous epochs, the abstraction dominated the design process. The conceptual idea only manifested visually at the construction phase. Until then, each recipient could subjectively understand the message. During the industrial era, the thoughts were mediated by drawings, which made the message more straightforward. Thus, the degree of abstraction decreased. While in the current digital episteme already, the concept can be visually expressed and generated, thus becomes over-determined and calculable from the first moment. The algorithmically expressible thoughts are usually lacking the potential of human abstraction and lets the outcome to be calculable from the earliest stage of design. There are no singularities, only singular space-time models, which simplified models are usually created to grasp a certain phenomenon in an understandable way. Talking about history usually requires these sterile and singular models, especially in order to emphasize certain regularities and patterns. In the singular space-time model of the epistemic design matrix, each episteme operates based on different mediums of communication, which mediums have become more and more formal throughout the historical development. By the time today, we have reached the algorithmic expressions, where the definition of formal language refers to a system of signs with a set of explicit rules to generate valid combinations of symbols. Formulas, syntactic rules, semantic rules. In Adversus Singularities, the ontology of space-time singularities, Romero argues that clarity and precision are made through formalization. As this paper assumes that digital design is more straightforward than any earlier design methods. Now, as it follows, the evolution of VFC is connected to three main milestones. One is related to quantum mechanics, the other is coming from systems theory, and finally, practically most important for our application is its advent to the gaming industry. Wave function is an algorithm, a mathematical description of quantum mechanics, which describes the quantum state of an isolated quantum system. The wave function collapse algorithms builds on the lowest entropy of space in a given grid. Collapse is one of two processes by which quantum systems evolve in time. The other is the continuous evolution via the Schrödinger's equation. Ludwig von Bertalanffy established the sequencing of feedback system as a part of general systems theory. This laid the groundwork for semantics and structure of procedural design. In a sense, it is a methodology that is used to test the relationships of parameters through iteration. Bertalanffy classified the components of feedback system by count, species, and association. While wave function collapse algorithms was developed by game developer Maxim Gumin in 2016 as a constraint solving mechanism. Gumin was inspired by convolutional neural network style transfer. VFC algorithms as an application of artificial intelligence sits on the borderline of machine learning, as connectionism, and also belongs to the subset of actionism. This process is very similar to style transfer in terms of populating a new outcome image based on an input image. But instead of style, it uses constraints to follow producing the outcome. On the other hand, it is also similar how cellular automata operates in a given grid, randomly fulfilling neighboring cells, but it applies strict rules and populates the grids based on the lowest entropy. The idea of having a building scale automated structure was first mentioned by Cedric Price, although since then many attempts are raising to find a way towards this intention. In the 60s, Archigram presented Plugin City. This provocative project suggests a hypothetical fantasy city containing modular residential units that plug in to central infrastructure megamachine. The plug-in city is in fact not a city, but a constantly evolving megastructure that incorporates residences, transportation, and other essential services, all movable by giant cranes. Persistent precedents and concerns of modernism lie the heart of plug-in city's theoretical impulse, not being limited to the concept of a collective living, the integration of transportation and accommodation to rapid change in the urban environment. Now let's see how wave function collapse behaves in a graphical pixel grid environment. What is the logic of autopoietic self-reproducing system? Based on the explanation of Paul Ambrosousen, the following pivotal points can be reviewed. Wave function collapse works with the texture synthesis. In computer graphics, texture synthesis is the problem of generating a large and often seamlessly twiddling output image with texture resembling that of a smaller input image. For the task addressed by wave function collapse, the values are associated with the discrete set of unique local patterns in the input image. The choice to assign a specific variable, a specific value, will often influence the available choices that can be made for other variables. Constraints relate the legal combination of values that set of variables might take on in a valid assignment. The allocation of elements on the grid operates like a Sudoku game. Each tile is looking to the lowest entropy. The algorithm can be understood as the constraint solver, where you have a set of cells, but you have to fill with the value of those cells depends on the neighbors next to those cells. Local similarity is determined by an argument which is called n. The n value determines how many pixels of the original image is selected at the same time, so how big the base unit of the output is going to be. The greater the n value is, the more unique output pattern can be expected, and the longer the time the compute of the output. In VFC, the solver repeatedly selects an unassigned variable and then decides on a value to assign from the variable's domain. If the solver encounters a partial assignment for which no subsequent variables can be assigned without violating constraints, the solver typically backtracks the recent decision, backing out of a dead end. At the top level, VFC performs 4 key tasks. It extracts the local patterns from the input image. It processes those patterns into an index that speeds up constraint checking. It incrementally generates the output image by growing a partial assignment. And finally, renders the total assignment back into an image in the same format as the input. In this process, the melange of algorithmical and visual representation goes to a very straightforward concrete workflow, which is meaningful for the human and the computer at the same time. Thus, the idea originated from an input image or shape is defined from the beginning of the design process. No classical abstraction is involved in the workflow when each recipient would imagine different outcomes based on the unclear notations. This free abstraction mutates to randomized combinations of the input image's pixels based on the lowest entropy. To build representations of the world, we use conceptual systems called languages. In ordinary life, natural languages such as English, German, or Spanish are or seem to be enough. If we want to penetrate deeper into the structure of reality, however, we need formal and less vogue languages like those provided by logic and mathematics. Using Python and Unity, the architectural application of VFC is promising. Building on a set of geometrical elements and a set of rules, it creates aggregations based on the given grid. VFC produces images by arranging a collection of tiles according to rules about which tiles might be adjacent to each other. The creation of the output image is based on how frequently the patterns appear in the input image. All these applications can be seen as the epistemic logic of design, meaning that what is occurring in the design field is in strong correlation with the current episteme. Compared to traditional design methodology, in this process, the result is unknown. The designer is not predicting the formal outcome and has no vision about the output, but creates a flexibly applicable set of rules. Only designing the rules and not the entire formal result, the strategy is more resilient and provides a flexible application. VFC operates based on epistemic logic, observational semantics, when an agent reasons based on its present observations. There is a certain urge in order to synthesize digital architecture into traditional architecture. The implementation of computational design techniques are usually questioned by the field, although sometimes the already existing context and coordinate system is inappropriate to inhabit new concepts. But if we still have to name a traditional application of VFC, that could be the housing realm, where building blocks and arrangements can vary in each application. The dichotomy of manual and digital calls for a distinct or new reference system and new understanding of architecture. In traditional architectural design form was the manifestation of the architectural thought, the idea and the embodiment of meaning. In the VFC, a set of instructions is generating the form. At this level, digital iterates from tool to a partner in the design process. It is meaningful that it makes possible to design the methodology of creating form instead of designing the form itself. One final output might be limiting, while the opportunity for many similar but not identical outputs results in the digital variability. The studied method illustrates that the relation of representation and information processing. The current Zeitgeist builds on big data and almost unlimited computational power, while earlier only filtered information could survive in a given canon. In the traditional design methodology, the workflow allowed more abstraction for the recipient at the concept and communication stage of design, while the exact formal and visual expression was born only at the construction site. Later, abstraction decreased when drawings were the transmitters of the ideas. The models to follow restricted the way of thinking during the communication process. At the digital era, using AI already at the concept phase limits the degree of human abstraction, while on the other hand, introduces a new form of algorithmic abstraction calculated by machines. This is how abstraction turns to algorithm from the human perspective. So now we are giving form to data instead of giving form to the idea. One urgent question still occurs when architects want to discipline computational design techniques in traditional architectural epistemes. Usually this approach cannot work based on the controversial manner of the two epistemes. Computational design differs in its nature from traditional architecture, thus finding its place in the well-known era is still challenging. VFC is most likely to be paired with housing, although in order to be applied in such a design era, it would need to alter the used materials and production techniques as well. The hybrid approach of VFC is a balanced symbiosis in artificial intelligence. The algorithm is similar to style transfer algorithms of convolutional neural networks, but still different since it is based on 2D or 3D objects and constraints, which makes it alike with the cybernetic approach, especially with cellular automata. The output is a 2D projection of either a 2D or 3D space rendered in Unity. After each training process, spatial analysis is done in TensorFlow based on density, gradient, orientation, structural connectivity, or planar connectivity. Populating a set of given tiles in a 3D voxel grid based on the lowest entropy, starting from different pivot points, results various outputs. The process is partially controlled with a decent degree of freedom. To sum up, in the new digital reference system, VFC is a set of instructions to be followed. Excluding the intuitive random factor, it operates based on present rules. In order to be conscious with the AI-powered digital tools, first of all, it is crucial to understand what do we call design, what is our logic of design, and what do we expect from computers to do. For what do we want to train them? Epistemic logic might help not to force the process to follow the human logic, but rather let it follow its own computational design logic, which might differ from the ordinary, but this way it can be self-identical. Thank you very much for listening to me. It's been a pleasure to be here and hope you have enjoyed the presentation. I will be happy to discuss further questions later on. Thank you.